So in Chapter 12, Exercise 11, they're asking you to draw the aldehyde or ketone that's formed when you oxidize some alcohols. Now, for our purposes, in Principles of Chemistry, in the organic chemistry section, oxidation means more bonds to oxygen. And to do that, we're going to make some room on the oxygen and on the carbon that it's bonded to by removing hydrogens. So let's go through this one. I find that the reactions are a little clearer to think about when we use skeletal structures, so I'm going to translate this into a skeletal structure. I like to number the carbons. That helps me keep track of everything. So this is 1, 2, 3, and then we have that OH coming off. So just a number to make sure it all lines up. 1, 2, 3 carbons, and then the OH coming off of there. Now, what we have is an oxygen, which is really important because in oxidation, we want to form more bonds to that oxygen. And to do that, we're going to have to get rid of a couple things. The first thing we're going to have to get rid of is the hydrogen on the oxygen. And the second thing we're going to have to get rid of is one of the hydrogens on the carbon next to it. Because both the carbon and the oxygen already have the maximum number of bonds they can. So if we want to form a new bond between them, we have to make room on both of them. So to do the oxidation, the first step is erase the hydrogen on the oxygen. Now that oxygen has room for another bond. Then erase the hydrogen and the bond on the carbon next to it. Now that carbon has room for another bond. Finally, draw the second bond between the carbon and the oxygen. And that's it. That's the product. And you can see that this is an aldehyde because you have a carbon double bonded to oxygen, and then it has a hydrogen that's invisible here because it's a skeletal structure going out to the side. So another way you could draw this is you could have this here, and then you could have that double bond to the oxygen, single bond to a hydrogen. That's the same thing. So that would be the answer for this first one. Now let's see what oxidation would look like on this molecule. And again, I'm going to redraw this as the skeletal form, just so I can keep track of things more easily. Personally, it's easier for me to see the molecule and keep track of everything in the skeletal form. So I'm going to have a dot, that's carbon 1, 2, 3, 4, 5, 6. And I'm going to number this just so I can keep really good track and make sure I drew it correctly. On carbon 2, we have that bond to oxygen and to the hydrogen on it. Now, we also have a bond to hydrogen on the carbon bonded to the oxygen. So what we want to do is form another bond between the carbon and the oxygen. This is oxidation. We're forming more bonds to oxygen. But to do that, we have to make some room on both of those atoms. So you make room on the oxygen by erasing the hydrogen and the bond to that. You make room on the carbon by erasing the hydrogen and the bond to that. And then you draw that second bond between the carbon and the hydrogen. And now you have a ketone. So to redraw that all in one color, you would have this ketone. And so one of the things you want to take away from this is that molecules are classified by their functional group. The functional group determines how the molecule behaves. And you can turn one functional group into another using these reactions. So an alcohol can change here to a ketone. A ketone is when you have a carbon double bond to oxygen with a carbon on both sides. Let's see how this oxidation looks when we do it with this molecule. Now here, they already have it. They already have it in the skeletal structure, so I'm just going to redraw it for ease. And one thing that should stand out whenever you're doing an oxidation is the oxygen and the carbon that it's bonded to. We want to form more bonds between those. To do that, we're going to have to make room on the oxygen, and we're also going to have to make room on the carbon there. So erase the hydrogen on the oxygen. So now that oxygen has room for another bond. Erase the hydrogen in the bond on the carbon. Now that has room for another bond. And draw a second bond between those two. And so all in one color, that would look like this. And that would be the ketone that you'd get when you did that oxidation. You turned an alcohol into a ketone.